flexible drive like rope drive, etc. And that there we have seen that basically it's a kind of rigid drive, this gear drive, okay. And we have seen basically it makes a higher pair mechanism due to the line contact that we have in between the teeth which are in contact. And we have seen one like you can say particular consideration about the double throated worm and worm gear, okay, where we have surface contact and it makes it lower pair, okay. But in general, if someone asks you about what kind of, whether it is higher pair mechanism or lower pair mechanism, this gear drive, then the answer is higher pair mechanism, okay. So those things already we have discussed, and now today we will be discussing some of the advantages of gear drive. Like the main advantage, also sometimes it's a limitation. It's kind of like, as we have already discussed, the central distance between the uh, shaft, that in case of our gear drive it is generally less, okay. And actually this gear, the advantage is like it requires less space as compared to belt or rope drive, okay. And what later on you'll see by properly combining those gears, actually it's the words that we use for combination, or you can say connection of gear, is the meshing or mating of gears, okay. So you have to use those words, okay. So now in this particular case it requires less space as compared to belt and rope drive. The central distance between them also is kind of less, as well as the compactness is there. In the same space, what we can do, we can have multiple gears arrangement, okay. So in the arrangement of gear train we can have, okay. So it's like a race space. And then what happens, as we have already seen, that the transmission of motion between the gears, it is by the gradual or successive engagement of the teeth. And now because of that kind of connection or engagement, so basically there is no slip. So if there is no slip between them, that means no slip means basically no loss of motion, okay. So that kind of thing is no slip condition. So because of that, basically we can get exact velocity, okay. So exact velocity it can be obtained. So that's why they are, this gear drive, they are also known as positive drive. So sometimes some in interviews or maybe in competitive exams, it may be you might be asked this particular question. So what kind of drive is this gear drive, whether they are positive drive or what, whether positive drive, negative, etc. So they are basically positive drive. Why? Basically there is no slip between them. No slip between them means we already know, uh, for a gear drive to work, we have to have a minimum of two gears. They should be properly meshed. They should be properly meshed condition. And for proper meshing, definitely there are certain considerations that we have to consider, all those dimensions, etc., module of the gear, etc., etc. Okay, or the gear tooth profile. So those things definitely we have to consider. But the thing is, the minimum two gears we have, okay, two, and they have to be properly meshed. And after that, basically we can expect that some motion transfer or torque transfer will happen. So now in that particular case, what is our intention? Our intention is that basically whenever suppose gear A and gear B, they are in mesh, okay, two gears are in mesh. So basically our intention is whenever gear A, if it is the driver, if it moves, then we want that during that course of time, so gear 2 or gear B also, which is the driven, it should move, okay. And there should not be any like omission, or you can say there should not be any loss of motion. So that's kind of no slip, okay. So now here, this gear drive, which also is a kind of rigid drive, and they are capable of transmitting higher power compared to belt drive or chain drive. So that is another advantage. So for transfer of, you can say transmitting of higher power, okay, higher level of power, so you have to go for this kind of gear drive. It is capable of doing so. And basically it's comparatively more efficient and effective means of power transmission. So these are some of the advantages of gear drive, or you can say why we go for, or why, depending on, we already have so many drives and where to, or these are some of the advantages. And you will know, if you know about this, then we will be able to select, suppose whether you have to go for a chain drive or belt drive or that kind of flexible drive or other type of drive, or you have to go for gear drive. So some of the limitation already we have said. So central distance, if it is when it is more, then you have to go for those wheel drive, rope drive, etc. But in case of gears, generally central distance is less, okay. That is somewhat limitation, you can say, okay. But the thing is, we can have a arrangement of gear trains kind of arrangement, whereby we can have more than two gears which are in mesh. Successive meshing will be there, and thus from one gear to another, suppose from the now second gear to third gear and so on, we can have the transfer of motion, and somewhat that central distance, it can be increased, okay. So that's possible. So understood this thing, all of you have understood, right? Just let me know. Someone may please let me know.
Yes, okay.
Okay, thank you. So now I will be going for basically some deducing some relationship, or we'll see try to see how basically these gears, okay, how basically these gears, how their size dependent, or and so. And prior for discussing that, we'll be going for a like very basic gear-like structure, which is a very primitive kind of structure known as the friction wheels. So previously, what we had, the persons who were like in the uh, previous years. So previous years means I am not talking about this 19th century or like that. We're talking about the older time. So basically, what happened? So prior to manufacturing of when we don't have even have the concept of those all those gears etc. So basically, what happened? Then also we have the need, right? The human civilization actually it is based on needs. We have got certain needs, and to accomplish that need, we do something. We progress like that, right? So there also definitely we had the importance, or we had the requirement of transmission of motion from suppose one sub to another. Yes, definitely there it was. So in that particular case, what basically people have seen how they have developed this concept. So maybe some people they have seen that suppose where actually we had suppose some combination of this. Suppose they have seen my suppose this is my sub, the one sub, and suppose this is the case, okay, and suppose these are the two subs, okay, center point of the sub. So basically the what suppose we had the motion here. So we have got the motion here, suppose it is rotating, okay, and suppose we needed some motion here. So suppose this particular shaft is there, okay, and we have the initial motion here, and we required something some motion here. So yesterday itself we have discussed. So by the proper selection of two gears, okay, which should be properly engaged and all. So it's possible to get this particular transmission of motion from particular this shaft to that this particular shaft. Okay, so those things already we have discussed. So now, initially, what do you think? Whether do you think that they have directly the people in the human civilization directly they have developed the gears with all the sticks and all? So definitely no. So the situation might be something like this. Maybe someone has seen that if I have some two elements, okay, and if they are in contact and all, okay, then maybe if there's motion from here, it gets this is capable of if suppose this element is there, okay, suppose element 1 element A, and suppose I have got B, okay. So what they might have seen that if suppose I have this, okay, suppose like a this kind of structure maybe, okay, so if it is in contact with some another this kind of structure, so some motion gets we get some motion here, we can expect some motion here. But initially we had the motion here, now it's kind of a magic thing and we are getting the motion here. Okay, so maybe this was the first they have seen that they have observed and they are trying to utilize it. In that particular case, so this kind of arrangement they might have, and they might have come up with this kind of arrangement, and later on maybe this kind of thing they have mounted on this particular shaft, and on the another shaft where they require the motion, maybe they have connected the another this kind of this like shape, they have contacted them, and maybe they have seen that some motion is being transferred. Now first step they are able to do that, okay, no problem. So one is like this is moving like this, and during this course of time when they are in contact, so it is moving like this. Next, what they might face, they might face some problem. Suppose initially they are happy with, suppose I am able to do this, see this magic, I am able to do this and all. But later on their requirement might have changed, and they might be thinking, suppose if this is rotating, suppose they definitely didn't have the concept of RPM or not, but they will be having some concept of suppose it is rotating at whether high speed, whether it is slow, whether it will be like high or that kind of, they might not know it quantitative, but qualitatively they might know the positive high speed, low speed, and all. So they might have seen that it's not that much sufficient efficient in transferring suppose high motion. Okay, so that is one kind of limitation they might have seen. Similarly, they might have seen suppose whenever they are suppose they have utilized this for certain task, and whenever they are going for high power or high energy like task, basically they fail. Okay, they are unable to, as we have already discussed, those like transmission of motion of power. Okay, that is also, those are interlinked, and they might have seen that for higher power requirement and all this kind of concept fails. And later on, I think maybe it may so happen that they might have seen, they might have observed that whenever actually if they have this kind of irregularities there in the surface, okay, so whenever because of this particular irregularities and all, actually like they initially didn't know about the interlinking and all, but definitely even though I am drawing it like a perfect circle, because this is the tool which is available with me, which makes a perfect circle, but definitely when whatever like stone etc they have used, definitely it was something like the periphery might be something like, sometimes it will be something like this, maybe some other stone it was something like this. Definitely it was not exactly circular but something like this. And because of this engagement, okay, something like this kind of interlinking of the surfaces etc, this kind of thing phenomenon is happening, and because of that actually this is able to, the force transfer was there, okay, torque transfer was there, and it was able to give some motion transfer from this particular element to this particular element. So basically from there, later on they might have seen whenever the surface gets worn out, the transmission loss happens, or maybe whenever a particular surface is kind of somewhat more smooth, if it is more smoother and engagement is not proper, then maybe they might have observed that the transmission of motion is not that good, and maybe gradually they have come up with, suppose, more rougher surface and all, or and thus I think that from the time of maybe in making the wood shape, like this gear kind of shape from wood or stones or like that, we have come up with the today's whatever we call as different types of gears. Now initially definitely they only have those mostly the wood structures and all, which resembles whatever nowadays I call as, or stones and not stones, sorry, so wood structure whatever we call nowadays as gears and all, okay, and they might have used it, and there they have come up with this kind of teeth on the periphery, and they have seen if they are able to properly engage the teeth and all, okay, between two this element, okay, from where they want to get the motion transfer from one element to another, then it is better. So maybe this was the thing, okay. So now this kind of wheels, whatever primitively we have used, okay, to transfer motion from another one to another, which is due to primarily due to the engagement and the friction that is there. So those are known as the friction wheels. And now, basically, prior to discussing about gears and all, how basically they work, will be discussing with respect to this kind of structure, which is the friction wheel. Okay, so now how basically the function transfer etc, or how they're interlinked, size etc, so that thing we are going to discuss. Okay, so now this friction wheel whatever we are talking about, okay, so there, as I have already discussed, so kind of this kind of wheel can shape, okay, which can be engaged and all, and we can, it's able to transmit motion, so they are okay for small level of power transmission. But as we increase the power transmission, okay, definitely there will be some slip, and the motion will not remain definite. So one of the very importance of using any mechanism is we are talking about all those constraint kind of motion or definite motion. So we must know what basically what is the, if we give a certain input, what is the output and how it is going to be. So it has to be predictable and we should be able to know it. Okay, so that kind of requirement is there. But whenever if we're talking about all this friction wheel and all, and if, definitely whenever we will be going for higher power transmission, so in that case sleep will be there and motion from one to the other will not be definite. Okay, so now suppose for analyzing purpose, how can we analyze them very simply. So see, why we are analyzing basically this kind of friction wheels, you may wonder, we are talking about these gears and all, and I am right now discussing about friction wheel and we are discussing with respect to this. So the basic concept is why we are doing with respect to this is actually, later on we'll see that there will be, when we'll be talking about the nomenclature of gears, we'll be seeing then with respect to certain design parameters like different circles, prime circle etc, we define the engagement or the designing of this particular gears. So in that particular case later on you'll see that one of the very important important circle that we define is kind of prime circle, okay, with respect to gears. And actually at the prime circle, or at the prime like with respect to that, actually pitch circle, not sorry, it is not prime circle, pitch circle, okay. So with respect to that only, basically the contact, etc. Suppose if you consider this as the gear figure, okay, gear 1 and gear B. So what we can do is, in actual case, if we're talking about a spark gear and all, okay, so something, the look will be somewhat like this one, not this one. But the contact, if you see contact between the teeth, actually the teeth are contact, okay. So that basically how basically we can define them. There will be some circles, with respect to some circles we'll be able to define. Actually the contact will be at the pitch point, or if we discuss the circle, then it becomes the pitch circle. So ultimately the discussion of the gears in a easy manner we can do with reference to this particular circle. And that's why later on also, sometimes whenever we are talking about all those, we are discussing the gears, you'll see that sometimes we may even draw the gears like this, but actually the gears, they will have some teeth on the periphery, okay. So that you must understand, but it is for easy analysis purpose why we are drawing like this, okay. So now, if we consider there is no slipping between the surfaces, these two surfaces, right now this is gear A, gear suppose B, then what will happen? So at this particular uh, here, basically, if suppose one is moving like this, okay, so if suppose this gear is moving like this, okay, suppose this is the driver A, and from here, suppose driven gear, it is getting the motion, okay. So then it will rotate. If this is rotating in the anti-clockwise direction, then due to this engagement, it is second one is, this is the driven is going to rotate in the clockwise direction, so direction has already changed. But the thing is, at this particular point, actually if we discuss about the velocity at this particular point, basically they have got the same velocity, okay. So now with respect to that only we are discussing, okay. So basically whenever there is no, if you consider there is no slipping between the two surfaces, then we can talk about their linear velocity, and it will be same for both of them. So we are discussing it with vp, v suffix p. So vp, it will be for one also, driver and driven, both the case, actually it will be the same, okay. So now how we can write this vp, that is the linear velocity. So we already know v equal to r omega, okay. So now if we consider suppose the disc A, that is the friction wheel, okay, or if you discuss with respect to gear, then suppose if one is rotating with angular velocity omega 1, and suppose two is rotating with angular velocity omega 2, and their size, if its radius is suppose r1, this for this one radius is suppose r2, in that particular case we already know, like this velocity vp, it's going to be v equal to r omega, that we already know from your engineering mechanics knowledge. So we can write like r1 omega 1, which itself is equal to, it is the same velocity at this particular point, contact point, which is itself is equal to r2 omega 2. And omega already we know, omega 2 pi n by 60 we can write, okay. So 2 pi for n, it will omega 1, it will become n1. Similarly for omega 2, second one, it will become n2, okay. So 60 we can cancel, or if it is, if we consider the 60, then it will, if we don't consider the 60, it will be in like in terms of mean, okay. So now I can write like this, okay. And now if we consider these two, then 2 by 2 pi get cancelled, and I can write like what we can get. We can get a relationship between the velocity, angular velocity, or maybe the rpm with respect to the size. So what we have seen, we can write like omega 1 by omega 2 equal to r2 by r1, which itself is nothing but n1 by n2, okay. So what does it shows? It basically shows that the speed of the two disks which are rolling without slipping, basically they are inversely proportional to the radii of this disk, okay. So this is important. So they are inversely proportional to the radii of this. So what does it mean? it means that as the size of the disk increases, okay, so that speed is going to decrease for the same power transmission, okay. And this is one of the understanding or relationship that we consider while designing all those gearboxes, etc., or you can say like in your automobile set and all, okay. Whenever we have to increase speed, so later on you will know what kind of whether the bigger wheel arrangement is going to give you the increased speed level or decreased speed level and all, okay. So those kind of things we will know. But right now what we have understood, I have understood that the speed of the two disks, which itself later on will be able to discuss with respect to the gears, okay. So the similar thing is happening with the engagement of gear. So basically this particular speed is, it is inversely proportional to the radii of the disk. And radii, basically what does it indicates? It indicates about the size of the gear or the disk, okay. And now once another thing what we have seen, so when this disk one, suppose this a, this is suppose is the driver, and suppose because of this two is the driven. So whenever it is rotating in this clockwise direction, then this two is rotating in the anti-clockwise direction or vice versa, okay. So now the thing is, if later on suppose this one is first case, okay, driver, this is the driver, and this is the driven, okay. So later on if we engage, we'll discuss with respect to the gear train arrangement. So what else we can do? Yesterday we have discussed that for changing the speed we can use suppose this kind of gear drive, okay. That means suppose 500 rpm to suppose if you require to send suppose to 1000 rpm, your requirement is something like this. So this kind of motion transfer can be obtained, can be done with the help of properly selecting a pair of proper machine gears. So this is the thing, okay. It depends on this particular size. So you have seen that basically how the transfer will happen. So later on we'll solve some problems and all, and it will be more clear. So this kind of thing can be done. So we have similarly the all reverse is also possible. That means from higher speed to lower speed reduction, that also can be done, okay, which are frequently done in many automobiles and all, okay. So similarly what we have discussed this the sense of motion, that means clockwise to anti-clockwise sense or anti-clockwise to clockwise sense. That sense also is possible. And what we have already seen, if we are only discussing up to this one and two, only these two type two gears which are in mass. So in that particular case, if gear one, the driver is rotating in the clockwise direction, then the driven is going to rotate in the anti-clockwise direction, okay. So that conversion is possible. But once again we have also discussed yesterday that also keeping it same also is possible. That means clockwise to clockwise itself also is possible. But in that case generally we go for this gear train arrangement, and then the middle gear becomes the idle kind of gear, and it is just changing the suppose the direction, as well as if required it can change the value also. And after that, then what will happen if we consider this portion now, okay, second and third, and suppose this is the third wheel. So in that particular case what will happen now, the second one is rotating in the anti-clockwise direction. So what will happen here? So this one is rotating in this particular direction, okay. That means once again clockwise direction rotation we have obtained, okay. So this can be done. Understood? Just let me know whether you have understood this concept or not.
Yes.
Okay. Others also, I hope all of you have understood. Now, so some of the classifications we'll see. So this classification of gears, it can be done in various ways. So one of the classification is we can consider on the basis of the velocity of the drive. So on the basis of this velocity of this gear drive, so we consider them as low speed gearing, we have medium speed, we have high speed gearing. So what are the numerical values up to which we consider it as like low speed gearing, or whether we'll be terming it as medium speed or high speed? So basically this particular linear velocity we are talking about, right? So the speech line velocity. So with respect to that velocity we are talking about. So right now, if we're talking about the low speed gearing, so this VP, it is basically up to a limit of 3 meter per second. And medium speed gearing, generally the range is from 3 to 15 meter per second. And whenever it increases 50, process 15 meter per second, then we term it as high speed gearing. Okay. And apart from this particular type of classification, there is also another more important type of classification which is done based on the position of the axis of the shaft. So as we have already discussed that basically the shaft positions are important, the central distance is important, and we're saying that mostly this particular gear drives we are using for transferring motion from one shaft to another, right? So in that particular case, the orientation of the shaft or the position of the shaft, they might be different. They might not always be kind of parallel, or some requirement might be different. Okay, so in that way, actually, the major classification of gear is basically done. Okay, so what are the different classification that we can have the classification for parallel shafts. So in case of parallel shafts, so there will be multiple different types of gears. So whatever gears we are basically you mostly see and we generally discuss with respect to spar gears, because spar gear has basically all the elements which are there in the gears, and all the nomenclatures we can get, and the indication of different velocity ratio and all. Okay, so all those required terminologies we can get with respect to it. So that's why in general, and like we generally see the spar gears, and they come falls under the parallel sub arrangement. Okay, similarly we can have for skew sub, that means when the axes are intersecting. Okay, so that kind of arrangement we can have. And for parallel sub we can have those spar gear, helical gears, etc. Then we can have intersecting subs, bevel gears, etc. We can use different skew sub, that means non-parallel and non-intersecting. Okay, so that kind of classification also we'll see. But going to before going to this particular classification, we'll talk simply something about the gear materials, or what are the different gear materials and why it is important. Okay, so now these gears definitely they are kind of physical entity only, and if we are talking about any physical entity, that means they will be made of certain material. Okay, and now in case of gears, as we are talking of this particular gear, and it's used in various service which are related with motion and power transfer. Okay, so in that particular case, the selection of the proper gear elements for a particular application is important. So this gear material selection, they actually depend on the type of service, what kind of service you require, what is the speed range, peripheral speed, the type of manufacturing method that is available with you, and the degree of level of accuracy that you want. So these are some of the factors, okay, which dictates which is the particular gear material that you are going to select. And a variety of different steels, okay, and cast iron, bronze, etc. are possible. Apart from that, non-metals gear, metallic gears also we have, which are made from, supposing say days like woods and all, can have textile, and in different with respect to different polymers also we have gears. So all those plastic gears that you have seen in your toy cars and all, okay, which you broke in your while playing, so those are like made of polymers. Okay, and some of the important materials are like, so the steels. So generally, when the gears made of steel, they are generally strong and highly resistant. Okay, and they can be very easily machined with the required level of accuracy, and the heavy loads also it can transfer. So when this is the case, then it will be you can go for steel gears. And similarly, cast iron. This is one of the versatily used most used gear material. Okay, and why? Basically, it's because of its good wear resistance properties and excellent level of maneuverability, and it can be very easily cast to any desired form. Okay, so apart from that, sometimes when you have to withstand like heavy sliding loads, okay, so then you can go for bronze gears, and generally in that case of the worm gear drive, which is capable of taking these heavy sliding loads, we make it of these gears are made of bronze. But apart from that, even polymer, etc., those are also used. Okay, and non-metallic gears we can have, metallic gears we can have. Okay, understood? Up to this much, any confusion? So basically, it depends on the process that you where the service that you are working on. Okay, so even though we are saying that polymers, etc., is used, but if the service is something like high temperature application, then definitely we are not going to go for polymer metals and gears and all. Okay, then we have to select the appropriate material. Understood?
Yes, sir.
Okay. So the as we are discussing about the classification of gears, okay, the most important one I have said that is based on the relative positions of their shaft axis. That means whatever diagrams we have drawn. So here we have shown, suppose this is the shaft, Okay, suppose this product portion is under sub, or suppose gear A and suppose gear B. So in that particular case, actually, why we're talking with respect to shaft position? Because the importance is actually we want the motion here on the shaft. The shaft is rotating. Okay, and how? Why the shaft is rotating? With the help of these gears, because we are mounting gears here. We key the gear with respect with the key with the shaft, so that whatever is the velocity of rotation of this particular shaft, we get the same velocity of rotation on the gear which is mounted on this particular shaft. And next, now this gear is engaged with or in meshed with the another gear, and it transfers the motion to this one. But whatever is the motion that has been transferred to second gear, okay, so now from this gear, actually, as this gear is keyed to this particular shaft, this shaft is also going to get the same velocity. Okay, and that's why later on you'll see sometimes even if we discuss the gears with respect to shaft velocity, then also you must remember, suppose if we say, suppose driver shaft is rotating with suppose 500 rpm, driven shaft is rotating with suppose this, what will be the driven shaft velocity and all, then you must remember that whatever is the gear that has been mounted on the driver shaft, it is also going to get the same velocity as that of the driver shaft. Okay, because it is keyed to it. It is there mounted on this particular segment. Okay, so sometimes it may not be discussed with respect to gear velocity. It may be discussed with respect to shaft velocity. But you must understand that the meaning will be same only. Okay, so now sometimes what may happen, the subs from where from one to another you want to like transfer the motion, they may be parallel. Okay, so in case of parallel sub, the different possibilities of gears that you can use is spar gear, which is very common, rack and pinion, you can have helical gears, etc., which can be used for parallel gears. Also, it may be like intersecting stuff. Okay, sometimes we may have intersecting stuff where also we have to transfer from motion from one to another. So in that case, we have available dual gear that can be used. So we can also have skew subs which are non-parallel and neither parallel nor intersecting. So in that particular case, we have worm and wear gear. So those are the types of gears that we have seen. So first type, I think this classification will do one thing. The classification of different gears and the terminology of the gears, okay, we'll be discussing in the next class. But today's class, basically, what is the importance that we have obtained? Like size dependency with respect to the velocity and size dependency that we have seen. Okay, whether the bigger size, like depending on whether if you want to increase or decrease the velocity of a particular gear, okay, velocity of a particular gearing, so what kind of size or how they are related with respect to size that we have discussed. Okay, and how they are related, basically what actually happens. So actually, what we have seen, that omega 1 by omega 2 or n1 by omega n2, it is inversely proportional to the radius. Okay, that is omega 1 by omega 2 is equal to, you can say, r2 by r1, or that can be translated in terms of the diameter, which can be written as d2 by d1. Okay, because 2 into r gives you the diameter of it. Okay, so that is the thing. So size dependency we have discussed. Okay, size and torque dependency. So this for today we'll stop here. And if you have any question, you can ask. And in the meantime, you can look at this particular animation and how basically these two gears are meshed here. The teeth are in contact. So later on, we'll be discussing about all those contact ratio and all. And you can see when this particular gear B is rotating in the clockwise direction, it is rotating in the anti-clockwise. Gear A is rotating in the anti-clockwise direction. Right now, we are not specifying which one is the driver and driven, but generally, if nothing is being specified, the smaller gear is considered as the driver, and in that particular case, we use the word pinion for it. Okay, gear and pinion. You might have heard the words. So generally, to distinguish the bigger and the smaller gear, okay, then for bigger one we use the word gear. The smaller one we use the word pinion. Okay, and we sometimes consider the smaller one as the driver, bigger one as the driven. But vice versa, it is possible. If nothing is mentioned, you can write your own assumption. Suppose this one, considering this one is the driver, this is the case, and so on. Okay, so with this we'll stop here. If you have any question, you can ask me, and if you have understood, you can let me know.
Understood, sir.
Okay, others, what about others?
Understood, sir.
Okay. So then in the next class we'll be going for all the classification and when a particular type of gear is used, and later on we'll see about the nomenclature of the gears. Okay, so with this we stop here. Thank you everyone for joining.
Thank you, sir.
Okay.